we present a framework for building online, adaptive, and real-time controllers for contact-rich dexterous manipulation. We start from 4 existing human motion capture demonstrations from the publicly available GRAB dataset. Our framework then builds online controllers for the widely used Allegro hand entirely from each individual demonstration. To do so, we use a multi-step process. First, we retarget time-indexed contact areas from the demonstration. Next, we use the retargeted contacts to produce a high-quality kinematic trajectory for the target hand. We next summarize the contact areas to improve online performance, and then perform a principal component analysis of the retargeted trajectory to transform individual degrees of freedom into more useful synergies. Each time-indexed PCA curve is stored as a B-spline to reduce complex motion to a limited number of control points. PCA curves and summarized contacts are used as controller inputs. Our policy follows a standard model predictive control formulation, with the 2 key differences being the summarized contacts as a cost term and the control points of the PCA curves as control inputs. The resulting optimal control problem is solved online using straightforward predictive sampling. Ablations across all tasks consistently show dramatic performance improvement with the addition of corresponding contact distribution costs. And consistent, meaningful task advancement at critical steps mid-manipulation, such as free-floating object pickup when using PCA sampling. Finally, here are some videos of full task completion using our online controller. Thanks for watching.